We are continuing with factoring. I want to just emphasize here that you are going to continue to see factoring problems like we saw the past few days. So you're still going to see factoring into two sets of parentheses. You're still going to see difference of two squares mixed in. But now we're going to introduce another layer where we're factoring by GCF. And GCF means greatest common factor. So one thing that can really help us when we're trying to factor is that if we have this common factor that all of our terms have in common, we can divide it out, and then we're left with smaller numbers that we're trying to factor. So again, this is pretty much the same set of instructions you've seen the past few days. We still write our quadratic in standard form, but this is new. We then factor out the GCF, or greatest common factor. If there is one, there's not always going to be a greatest common factor. Once you've done that, you're going to factor just like you normally would. So use that reverse distributive property, break it into the parentheses, set the parentheses equal to 0, and solve for the variable. So here's an example. One thing that I will say is that you've got two terms here. And in the last set of notes, I said if we have two terms, we should look for difference of two squares. But that's not always the case. We're not always going to have a perfect square minus a perfect square. So we're going to add to that, if you have two terms, look for GCF. Do those two terms have a common factor? So when we look at this example here, this is in standard form because it's x squared followed by x. There's just no constant term, and it is set equal to 0. We do have a greatest common factor here. If we look, x squared and 6x, they have an x in common. So our greatest common factor here is an x. So essentially what we're going to do is we're going to divide all of our terms by x and pull that x out of parentheses because that's like our reverse distributive property. We're taking that factor out. In parentheses is what's left. So x squared divided by x is x, minus 6x divided by x is 6. And again, the reason we keep this x outside of parentheses is that if I were to redistribute it through, I would have x squared minus 6x, which is what I started with. Then we're in factored form, and we know we can't factor any further when there's no exponents left. So I'll say I can't factor anymore when the highest exponent is 1. So we don't have two sets of parentheses because of this x that was the GCF, but we can't factor any further because that's an x to the first and an x to the first. So now any chunk that has a variable attached to it gets set equal to 0. So we've got an x equals 0, x minus 6 equals 0. X equals 0 is already solved. Here you add the 6, and we get x equals 6. Here's another example, and this one looks kind of ugly because you've got all kinds of x's, there's stuff on both sides. Start by putting it in standard form. So you're going to subtract 12x and add 48. I'll squeeze that plus 48 in here. So we want standard form, so 2x squared comes first. Negative 16 minus 12, that's going to be a minus 28x, and then we've got a plus 48 equals 0. Now, we could try to factor this, but removing the GCF makes it easier for us to factor. So here, we want to identify what all three of these terms have in common. So all three of these are divisible by 2. So we're going to divide a 2 out of all three terms. That 2 is going to go in front of the parentheses, and then what's left over goes inside. So 2x squared divided by 2 is x squared. 28x divided by 2 is 14x. 48 divided by 2 is 24. Now I'm going to come over here. I'm just going to rewrite what I have. I'm going to keep that 2, but now I can still factor because I have this x squared. So I want to break this down exactly like we did in the previous lessons. So x times x is the x squared. This 24, I need to think about it. Okay, I could do 1 times 24. I could do 2 times 12. I could do, 3 and 8. I could do 4 and 6. I need to figure out which combination here will give me an outside plus inside term of negative 14. So kind of looking through my list, I know the 1 and 24 is not going to do it. That 24 is too big. 2 and 12 is actually going to work because here my outside terms are 12, my inside terms are 2. If they're both negative, they'll combine to give me negative 14. So now anything with a variable gets set equal to 0. X minus 2 equals 0. X minus 12 equals 0. Add the 2 to get x equals 2. Add the 12 to get x equals 12. And you might be wondering, okay, in the last example, we took this number and set it equal to 0. It was because there was a variable out here. There's no variable, so we can't take 2 and set it equal to 0 because that would give us an untrue statement. There's not a variable to solve for in this example. Here's another one, only 2 terms. So in my head, I'm thinking, okay, maybe difference of 2 squares or maybe GCF. This is not a perfect square minus a perfect square, so we can try GCF. Both of these terms have an x in common. So we can divide an x out of both terms. X squared divided by x is x. 11x divided by x is 11. At this point, I can't factor any further because my exponent is, or my highest exponent is 1. So every variable component gets set equal to 0, including this x out here. So x equals 0, x plus 11 equals 0. We can subtract 11 and get x equals negative 11. This one, don't be thrown off when the equal sign is on the left. It's the same process for factoring. It's just written kind of opposite what you would traditionally see. This one, again, does have a greatest common factor. All 3 components share a factor of 3. So I'm going to divide all 3 of these by 3. So put that 3 out front. 3x squared divided by 3 is x squared. 21x divided by 3, that's going to be a minus 7x. 36 divided by 3 is going to be 12. I still have this x squared, so I still need to try and factor further into 2 sets of parentheses. So I'm looking at 12, okay, maybe 1 and 12, maybe 2 and 6, maybe 3 and 4. I need to get my outside and inside terms to give me a negative 7. The only way that's going to happen is with the 3 and the 4. I need them to both be negative so that they add to negative 7. So I've got x minus 3 equals 0, x minus 4 equals 0. Here I get x equals 3, and here I get x equals 4. Okay, here's another one. We're back to a 2 terms example. So again, 2 terms, we think maybe GCF or maybe dots. We do not have a greatest common factor here, but we do have a perfect square minus a perfect square. So we can follow that dots pattern. And again, that was if we have a perfect square minus a perfect square, it factors into the square root of each term, 1 positive, 1 negative. So square root of 36x squared, that's going to be a 6x. Square root of 25 is going to be a 5. 1 positive, 1 negative. Again, here in this case, you are going to have that 2-step equation to solve. So you've got 6x plus 5 equals 0. 6x minus 5 equals 0. So move the 5 over and then divide by 6. So on the left, you have x equals negative 5, 6. Over here, add the 5 over and divide by 6. So x equals 5, 6. So for your assignment tonight, you have factoring worksheet 3. This is going to be a mix. So look for standard form. Look for dots. But before you would do either of these, make sure you remove the GCF if you have one.